Okay, here we're in example 2, 3, and 4, and 3.5. Now, we have special forms that we could utilize here, but they might take a little time to remember. We can always reproduce them if we need them, but I will cite some of them when they occur, so you might recognize them. Special forms, we'll talk about that in a minute. Okay, here's the argument here. So remember I said at the beginning of the unit that we would start with statements, determine truth values for statements. Then we would make more complex statements with our connectives and determine the truth values for those complex statements. And then we would put these statements together in arguments and decide if the arguments were valid or not. So here we're going to try to find if an argument is valid. So here's the argument. This is the form that we take here. And this, our first statement is if P, then Q. Okay, that's given. If P, then Q. Then it's given to us that not Q. So whatever Q was, this is not Q. Well, if that's true, then according to this argument, not P must then also be true. So if you put these together in an argument form, we can say the whole thing in one statement, and that's up here. We put them together with an and. So whatever these are the premises in here. This is premise 1, and this is premise 2. And we join them together with an and. And that all of that becomes the antecedent for this therefore. In other words, this is the if portion. And this is the then. So we can put that together as one statement up here. Now we have to decide whether or not it's valid. So ultimately, this is a conditional statement. As you can see, overall, it's a conditional. We have the antecedent is this whole front piece in here, and this is the consequent. So now let's work on these here. We'll use our standard true, true, false, false. True, false, true, false. Gives us all the cases. So this is your standard conditional, and we know, looking at the P's and Q's, that this is the only time it's false. If you have a true P and a false Q, so these other times are true, these other cases. Now, not Q is simply writing in the negations of Q. So we have FT, FT. Now these together form this and, this conjunction. And we scan this looking for any double truths like this one. Here we have a true statement because two truths make a true. The rest of them must be falses because the and statement is only true if you have two truths. Okay, so that finishes that. Now that middle column is the entire value for the left side of this original statement here. We found the center column in here. Those are the values for each of the four cases for this left side, this whole left side. Now over here we have a not P, so just copy over false, false, true, true. Because we're going to look at these two to form our final conditional. So again, because it's a conditional, you're looking for a true followed by a false if you can spot one. So I look in this column here, and I see a true here. When I look over here, it's not a false, it's a true. So all of these are true. That means we have a valid, since all true, it's a valid argument. Okay. And this one's called the law of contraposition. Sorry. Yeah, that's the law of contraposition. Yeah. It's kind of complicated in this form when you put it all together as one statement, but we remember it in this form. And there's a table in the textbook that lists these special forms. Notice if you can kind of read this, if P then Q. So we know if P happens, Q will have to happen. So if we find out that Q did not happen, then there's no way that P could have happened. P would also have to be false. Because if it had happened, then Q would have happened, and we were given that Q did not happen. So this conclusion has to follow. Okay, that's the law of contraposition. It's kind of in a way it's saying that if you know this, then this is the equivalent form of that. And we know that already, that this is the contrapositive. In other words, this is the contrapositive. Whoops, that's my Q. This is the contrapositive of if P then Q. We know that from our last encounter with these 4 forms. Okay, number 3, you have if Q, let me just write it down here. If Q then P, not Q, therefore not P. Okay. Well, before we tangle with this on the table, let's think about it. If Q then P. This says if Q happens, P will happen, but it doesn't say. See, you can't read in things to it. It only says that if Q happens, P will happen. It does not say what will happen if Q does not happen. I mean, there are other ways that P could occur. This is just one way that it could occur. If Q happens, P will happen. So we don't know that if Q doesn't happen, then P won't happen. There might be other ways for P to occur, not just based on whether or not Q happens. So that's the false assumption when you read this the wrong way. So usually if you put a context to it, it makes more sense intuitively. For instance, if I go to the store, then I will buy milk. I didn't go to the store. Therefore, I didn't buy milk. Well, this only says I didn't go to the store. Maybe I could buy milk someplace else. Don't have to buy it at the store. So it's critical. All the words are critical in the statements. Anyway, from down here, well, let's start this true, false. Oops. Undo that. Okay, I want this true. True, we're going to stay with our form. False, false. And true, false, true, false. So our statement is going to be this. If Q then P, oops. And not Q. Then not P. And let's see what happens when we analyze it like this. Okay, so if Q then P. Well, this is backwards, so you have to look for a true Q that's behind a false. There's one here. True pointing to the false. Q points to P. So here we have a false, but these others are true. Not Q is just the negation of Q. Now we can finish this. This is an and it's only true if you have two truths. So we have mostly, well, it's half and half. Now over here, just put in the not P, which would be a false, false, true, and true. And these are the two that we're going to work with to form this final conditional statement, these values in this column. So again, we look for a true followed by a false. Here's one here. Now, as soon as you spot that, there's even just one of these is false, then the argument is already invalid. As soon as you spot one false in our final column. But we can finish it up. We've got truths in actually all of these other places, but the one false makes it invalid. That's all it takes is one. Somebody poked a hole, so to speak, in this argument. I find in the one case where it is false. Okay, and that makes the whole argument invalid. Now back over here in example 4, we have, by the way, this is called the fallacy of the inverse. The inverse. Okay, because notice, not Q, if Q then P, not Q, not P is in that form of an inverse. Not Q, not P. Okay. All right, let's continue with number 4 and one more here. This one's got a little bit different form. Q and not P. Not P. Therefore, Q. Does that follow? Well, hard to say at first. We don't. This is not one of our special forms. In this state, it's not. So, let's see what happens. Okay, again, fill in your forms here. Okay, a little silence there. I've got this thing, it's in my way on my screen. You can't see it, but okay, Q and not P. You know, I'm going to give myself a little more room on that just because I think I need it. Okay, so here's our single statement I have up in front here on top. And we can't move that around. So, all right, we'll do the best we can with this. Okay, so we'll copy down these true, false, true, and false. Okay, I lost the false there. Not P. Well, that would be false, false, true, true. And joining these together would make only a true here, and the others would have to be false. Okay, now let's put that not P in over here, which would make this a false, false, true, and true. And now this last column, okay, this last column, it will be based on this and this. Okay, so our last column here. We have an and statement, which is only going to be true if I have two trues. I see one of them right here. I've got this true and this true. So I have a resulting true, but otherwise, comparing the column values, I have falses here. Okay, now we're going to use that result with this not P, which makes this a false, false, true, true. And now with this conditional, we're looking for a true followed by a false. So now I see a true here, but it's followed by this true here. So I don't see any of those special cases, true followed by false. That means all of these must be true. And we have a valid argument. Whoops, valid. Okay. Wasn't obvious at first, but if you can kind of argue it if you look at without all this work here. If you look at the original statement, if we're to assume that this is true, if Q, the only way it could be true is if both of these were true. So we're given that not P is true. That's what it means to say not P. Okay, that means not P is true. So this side of the and statement is true. In order for it to remain true, Q would have to also be true. So you can't contradict one of the premises. And the premise is that this first premise is that this is a true statement. Q and not P, that's true. Second statement is that not P is true. So if I have a true on the right side, I must have a true on the left side in order to keep this first premise true. That's why the Q has to follow. Okay, so that's why we've got a true or a valid argument in this case. Okay, so that was a long one. Hope you hung on through that. I don't like to go that long because I understand it's hard to pay attention that long. Okay,